Hi. Yeah, so this is round two, Thursday, August 25th. And I'm hoping that you're watching this because you just finished the first video and you finished problem number 3. So I wanted to share with you what I got for question number 3. And again, this is a video, so you can pause and think about questions you might want to ask me in Schoology. We can try to interact that way. I'm going to ask you to turn this in. So if you could please make sure that you show your work and take a minute to copy this down if you didn't get it already. Looking on to problem number 4, it seems very, very similar. And so I do want you to take a moment and complete number 4 independently. I don't want to show that answer. I do want you to work with each other to try to get that done. Try to press yourself, stretch yourself, and give yourself a minute there before I go on to number 5. Okay. Question number 5. When I look at the first equation, it looks very similar to what you've been doing now for a couple of weeks. X-intercept, Y-intercept. The Y-intercept, I'm going to start by identifying that when X is 0, Y is 2, and that the Y-intercept is the point where the X is 0. So if I use my slope, I have a slope of 1. And if I keep traveling to the right, it's like I'm never going to intersect the x-axis. And so in this case, you are using the way I say is you're using the slope backwards. And this is only just one way to find the x-intercept. And so in this case, the x-intercept is -2. Again, I've got 2 goals here. Is that I want you to be familiar with the concept of intercepts, X and Y intercepts, that they're involved when I graph lines, and that graphing 2 lines is one way to figure out the solution to a system. So my X-intercept, if I was looking for it, is right here. And the way that you would write it as a point would be the number X first, and then the value of Y is 0 because it's sitting on the x-axis, and the equation of the line that is the x-axis is Y equals 0. So what I really wanted to give you a little bit more practice on are equations that are written in standard form, that there are different forms of a line, and y equals mxb is just one form, and this is another form. And the form of this line is actually ax plus by equals c. You don't really need to know that, but we see that often when we solve algebraically, because when we set up elimination, oftentimes it looks like that. But also, when an equation is written like that, it might be helpful to be able to find intercepts like that. So one thing that I've mentioned, and that is very important, is that the y-intercept is when the x is 0, and the x-intercept is when the y is 0. And that those are also equations of lines for the intercepts. And then I also mentioned that the reason why, or one of the reasons why maybe we start with the y-intercept, is because x equals 0 is easy to substitute in, because if you have to multiply by 0, anything times 0 is 0. So that's what makes intercepts easy to find when I'm not graphing and I'm just looking at the equation. So if I'm looking for the x-intercept, it's going to be when the y is 0. And then when I'm looking for the y-intercept, it's going to be when the x is 0. And I can solve the equation algebraically, and I don't need to use a graph. If I just take these and I sub them in, I'll get an x and a y answer. And those are 2 different points that I can connect and make a line. And I won't need to use the slope. So the original equation is negative 3x plus 2y equals 6. This is what I'm trying to graph. And if I let the y be 0, what's going to end up happening is I'm going to end up solving an equation. It feels like you're using elimination where that letter just goes away. It doesn't really go away. You're saying, well, if I want to know what the x is when the y is 0, I'm going to sub in a 0. And 2 times 0 is 0. And so that part of the equation is gone because negative 3x plus 0 is just negative 3x. And then you solve this little mini equation and you get x equals negative 2, but it has reference to a graph because the original equation wasn't negative 3x equals 6. It had an x and a y, and that's just the x when the y is 0. I'm going to do the same thing. Again, it kind of feels like you're solving a system. You're not. All you're doing is you're finding two different points that are on a graph, and it's the 2 points where either the x is the 0 or the y is the 0. So now the y is 0. So sorry, the x is 0. Sorry about that. And so if I let the x be 0, you know, if you wanted to see this step by step, it would be negative 3 times 0 plus 2y equals 6. But then this part just turns into 0 plus 2y. And so you end up solving a little miniature equation, 2y equals 6. Divide by 2, divide by 2, y equals 3. Again, this is not 1 point. This is not the point negative 2, 3. This is the point where y is 0 and x is negative 2, and x is 0, and then the y is 3. So this first line that I just graphed, it's on the graph already, right? And this is what you've been graphing a lot with me in this class. What is new information is how you can take the equation of a line that's in standard form, and instead of finding the y-intercept and the slope, is that you just find the two separate intercepts. Negative 2 zeros right here, 0, 3 is right here. And so this right here is that second line. You can find the slope if you want. But if all you needed, excuse me, was where they intersect, you'd find that they intersected right there. So I know this is a lot of information. I'm going to work through the next problem with you. And please just try to have this worksheet done by the end of the period so that you can turn it in. So what you want to try to do independently is find the x and the y intercepts by yourself. And just try to keep things sorted in your mind. I'm not using the same process, and it's just another way to graph, which sometimes makes it complicated, but when you know multiple ways, you can choose the way that's easier for you. So first thing I'm going to do is take 2x plus y equals 5 and try to find the x and the y intercepts. X-intercept is when the y is 0. And then the y-intercept is when the x is 0. And when the y is 0, it's like this part of the equation is gone. And then it just turns into 2x equals 5. You divide by 2. That's an improper fraction. 5 over 2 is like 2.5. The y-intercept, it's like what you'd get if you just covered up the x part. And it's me letting the x be 0. So the y-intercept, that one's a lot easier. The y is just 5. And these 2 points are both on this top line. And so once I know the 2 points, 2.5 goes on the x-axis, and then 0.5 goes on the y-axis, and I would use a ruler and try to connect them. So again, this is the point 2.50, and then this is the point 0.5, and they're all helping me graph this top line right here. The x-intercept is 2.50, the y-intercept is 0.5, and they're both helping me graph this top line. Finding where two lines intersect is not as accurate this way because the slope, you get like the whole number parts in between, but it's just another way to graph. When I look at the second line here, x plus 2y equals 10. First, I'm going to find the x-intercept by letting the y be 0. I'm trying to figure out what the number for x is. And then I'm going to find the y-intercept by letting the x be 0. So when the x is 0, it's like I can just forget this piece of the equation, and I need to solve 2y equals 10. Dividing y equals 5. Oh, man. I was supposed to let the y be 0. My fault. Sorry. If I let the y be 0, then this part's gone, and I get that the x is 10, right? X plus 2 times 0 equals 10, and then this just fades away. Now, this is a problem for me. That is the correct x-intercept, but I don't have a graph that goes out that far. And then the y-intercept is when the x is 0, so that's the one I was doing first. My brain saw it first. And then, well, what I'm thankful for though is that I don't really need to know or have space for it, because I just put this brown dot right on top of that orange dot. And if I'm looking for the solution to the system, it's the point they have in common. Two lines can only have maximum 1 point in common. And so I found the solution to the system. Oh, guys, I know, teaching math, people tell me it's very difficult, and I bet it's hard to concentrate. And again, I hope to see you guys on Monday, and I hope that you're doing good work. And you're not too overwhelmed. Please send me any questions that you have. I'm wrapping up the second question here. Hopefully you're doing the same. Please be kind to each other, be kind to your teacher, and turn this in for credit. I will see you soon.